Okay friends, welcome to part 4 of our video presentation on chapter 2. In this part we'll continue our discussion about computer software, but in the last part we will talk about the so-called support software. The software that enables application software to be carried out or run. Some of the main functions of support software is to ensure that computer hardware and software are used efficiently. And typically, support software is purchased from a hardware or software vendor, the one that supplies, specific hardware to a company, or a software company specializing in, developing a particular type of support software. Now, the most well-known and the most important type of support software is the so-called operating system. Usual operating systems are purchased together from the manufacturer of computer hardware. For example, if you buy a desktop PC, at Walmart, let's say, then most likely it will have an operating system, pre-installed. By the way, to kind of step back a little bit from hardware and software and take a managerial and put a managerial hat on, that was one of the smartest business moves made by Microsoft. I mean, Microsoft, started bundling, started giving hardware vendors this option of including their operating system together with their hardware platforms for a very low price, a long time ago. Now, if you think about it, it makes a lot of sense on a number of dimensions. First of all, the economics of software is such that making an additional copy of software, doesn't cost much. In other words, as economists would say, the marginal cost of making an additional copy of software is virtually zero. It's negligible, right? So in that case, it's not like, by allowing all those different vendors to pre-install Microsoft Windows on their hardware platforms, it doesn't cost Microsoft much on the downside. Now, on the upside, it gives them revenues. But of course, the impact of this tactic goes well beyond that, because everybody is buying computers with, or most of the people are buying computers with Microsoft Windows being pre-installed, and then that immediately makes them a Microsoft client, because once you have a Microsoft operating system, most likely you'll end up buying Microsoft Office as opposed to an alternative product. And also because Microsoft Windows is a proprietary piece of software, Microsoft has an advantage when it comes to developing their own software, because they can develop software that is working very well with their own operating system, and other software vendors may not have an advantage like that. By the way, this led to a number of lawsuits where basically Microsoft was accused by other software vendors in competing unfairly, because they felt that Microsoft has an unfair advantage with their products because they have access to Windows operating system. And I remember there were many court hearings, and I think at some point somebody was trying to force Microsoft to release the code of Microsoft Windows to make it public so that other software vendors can have access to it. I'm not sure what was the outcome of this demand. I think there was some kind of compromise where some of the code was to be released to software vendors or something like that. But nevertheless, it was a very smart move by Microsoft to make their operating system bundled with different hardware platforms, and that made them the strong, the successful, the powerful company they are now. But back to the discussion of operating systems. Operating systems, OS, they are complex programs that control operations of computer hardware and coordinates other software applications together so that they can all work, sometimes in unison, like using some kind of multitasking or multi-threading approach. The main objective of an operating system is to maximize work done, the so-called throughput of the system. And user communicates with the operating system as well by providing input, by receiving output, by managing storage, and so forth. Now, operating systems in the old days, they used to be command line based, like MS-DOS. Eventually, and Apple allegedly was the first company to show the importance of a graphical user interface where it's all point and click. So indeed, having a graphical user interface, or GUI, is much more convenient for an average user than memorizing command lines. And again, Apple saw potential in that. Allegedly, they borrowed their graphical interface ideas from Xerox, and then allegedly Microsoft borrowed those ideas from both Xerox and Apple. Some proprietary operating system for microcomputers or desktop computers, MS-DOS, and then Windows products, Mac OS, with Windows being by far the most widely used operating system. For large systems like mainframes, you have some operating system from IBM, When it comes to web servers and mainframes, the leaders here are open systems, such as Unix and Linux. There's one kind of terminology when somebody says IT platform and the acronym OS, operating system, usually suggests that they mean both, like a set of hardware and software. One example of an IT platform is Mac OS, because for a long time Mac computers, they use their own hardware platform and also their own software platform, their own operating system. So that's why Mac OS is more like of a platform, I guess. Then there are specific operating systems used for networks, the so-called server or network operating systems, or NOS. Some of the biggest players here include Unix and Linux-based systems, but also Microsoft has a substantial presence here with its Microsoft Windows Server products. So basically, those are network systems. They allow enhanced operating. They allow like enhanced features for operating things over the network, like sharing disk drives and printers. Handling server-side of client-server applications, so they're quite those kind of approaches are quite common in the corporate setting. Now let's talk about computer languages, the kind of languages that are used to develop software applications, both for personal needs and also for corporate needs. Now, at the end of the day, a computer can only understand machine language, the so-called first-generation language. So each instruction is expressed in a very tedious way that is unique for the specific platform or specific computer. A very simple operation can sometimes involve thousands of different instructions, and that's why programming in machine code is very tedious, if not time-consuming, if not impossible endeavor. So that's why second-generation languages were developed on the top of the first-generation language. So second-generation languages, they're a bit less detailed, and they involve like spelling out operations in a way that can be kind of understood by humans, and then you use an assembler to convert like assembly language into machine code. Now the good side, so this is how it works. Somebody writes code in assembly language, then under the control of computer, that assembly language is translated into machine language, the code that the computer can load and actually implement or run. Now one thing about assembly languages, because those languages, they're kind of one step closer to humans, but they're still hard to learn, and writing in assembly languages is a very tedious process, although code written in assembly language is typically very fast, and sometimes for some computationally intensive applications written in third-generation languages, people create those insertions in assembly language to maximize the speed of execution of that software. Now, third-generation languages, they're like kind of 2 steps or 3 steps closer to humans. They use like language that is fairly close to humans to express step-by-step procedures, instructions for computers. Typically, they are machine independent. Code written in a third language can be compiled or translated for different platforms, different machines. And because it's 2-3 steps closer to human language, it's a bit easier for programmers to learn and work with. Now, the early versions of third-generation languages, they use structured approach where a program was divided into specific steps. And then all those steps will be aggregated into modules or procedures where there's a definite entry and exit point. And then, they're compiled and interpreted, as we said. Now, a typical example, but the compiling procedure is similar. Somebody writes like code in third-generation language using procedural approach, then the computer compiles it into machine language. Then machine language is loaded into computer memory, and then that's where the work involving data input and data output is being carried out. Now here you see like typical steps in developing software application using third-generation language. It starts with identifying a problem. Then based on the problem, you develop an algorithm, meaning like a high-level approach to solution. Then algorithm is collected into some kind of computer understandable logic, usually in the form of a structure chart or pseudocode. Then the program code is prepared, and as a part of that preparation, or after that preparation, it's keyed into the computer. Then the code is compiled, and then once it's compiled, it's executed by the computer using some kind of test data. during the execution it's debugged, bugs, or errors are detected, and then, once it's all fixed, all the bugs are fixed, then the software applications is used with actual data by a real user. Now, of course, this approach, it makes sense, but it's also a bit naive, giving like modern approaches to software development, agile, all those approaches that require like high iterations between those steps. But nevertheless, this outline gives you a fairly good idea of how applications are developed using a third-generation language. Now, some examples of procedural third-generation languages were Fortran, COBOL, Common Business-Oriented Language. It was used in the business context for mainframes a lot. BASIC, this was one of the languages that many people started with. And then C. There is another language that was fairly popular in Europe and Asia, I think, but not as popular as in the United States. The language was called Pascal. It was, it was in a way like a training language developed specifically for students to learn the basics of programming. Now, all those languages are almost gone, but the interesting thing is that COBOL sometimes is resurfacing in some job ads, because there are some organizations out there, like some government organizations, who are running the so-called legacy code developed in COBOL for mainframe computers. And I think there is still demand for people who can understand COBOL and use it. So here you see an example of a COBOL program. It's like a highly structured code that has like specific areas where commands are written. It's probably too small to understand, and honestly I don't have any experience with COBOL, so I cannot really interpret what's written here, what kind of operations are being implemented here. It's also like domain specific, so it's something related, I think, to some kind of business batch processing. Now, fourth generation languages are one step closer to human language. They're easier to program, but unfortunately they're less efficient for computers to run. I mean, as you know, computers, they don't think the same way as humans, and the key difference between the way computers think and the way humans think and operate is that humans can tolerate ambiguity, computers cannot. They need to have very specific instructions. So basically, with the fourth generation language, a human being would write code in a sort of ambiguous way, and then computers would use their own judgment to translate those kind of high-level ambiguous way into specific commands or instructions. Now, some of the languages that fall into this fourth generation category, they're geared towards business intelligence, and others for not for programmers, but more like for business people to use. And they include the following list. Now, personally, I'm a bit familiar with SAS and quite familiar with R. And at first, I was I objected by saying, well, R is more like a third generation procedural programming language. It's not like a fourth generation. But then I remembered that indeed, in R there are interesting libraries or packages, like for example, packages for manipulating data, cleaning data. And I remember, if you're using a typical programming language, if you want to manipulate data, in a matrix or in a table, you basically need to use a bunch of loops, to go through the data, make changes. But in R, there are some packages like, plier package that allow you to basically tell computer how to manipulate data in a very human-like way. It's kind of saying, well, why don't you try to aggregate the data based on whatever patterns you see in this particular variable, and please aggregate it by mean or something like that. So it does seem to be very close to human language compared to how you would do it in a typical third generation programming language. Unfortunately, I don't have any exposure to other fourth generation languages listed here, so I cannot say much. Okay, another type of software or coding or software development involves markup language. Now, markup languages, they're not really programming languages because they don't have hardcore logic. They're more they provide representational logic. In other words, how a particular web page should be displayed. And then HTML, hypertext markup language, is the widely used language for creating layouts for web pages. Now, you also have XML, which stands for Extendable Markup Language. It seems to be an extension of HTML, because HTML has predetermined tags that are used to describe certain elements of a web page. In XML, you can describe pretty much anything. So here, in the next slide, you have an XML element that is used to describe a game between Indiana and Michigan. And also you have scores and date for that game, and the type of the game, college football. Now, XML is meant to facilitate information exchange between different web applications, because if you're talking about World Wide Web, there are many different computing platforms, software platforms, different browsers, and somehow all of them need to talk to each other. So XML, can provide this kind of shared way of understanding data available on the web. Object-oriented programming languages, I think sometimes they're included in third generation category, but some people argue that this is a new paradigm because they're not procedural. Again, I'm sure at least some of you are quite familiar with object-oriented paradigm. Typical object-oriented languages include C++, which seems to be like an object-oriented version of C, Java, Visual Basic.NET, C#. So at the center of this paradigm, the so-called objects. In other words, you can create objects, such as text boxes, check boxes, or some computational objects. And here you see an example of object in Java code. And then those objects can be reused or instantiated, once you need a similar functionality. So here you have like a class called dog, and then you customize this particular object for your own needs. Programmers, I think they borrowed this idea of object-oriented programming from life, from nature itself. Now, it's a very powerful tool. Like, think about it. Like animals and humans, they recreate by creating instances of an object, right? That share, that borrow, inherit something from the parent, and then have their own unique needs. And they do that without thinking about the design. And a horse does not design a new horse, right? They reproduce by basically using that object approach. Horse creates this object called like a new horse, right? That borrows, some of the properties from the parent, but also has some unique properties. So they borrowed it from nature, and I think the most important goal of object-oriented programming is to maximize performance of computer programmers. Just like horse, creates another horse in a very short time span, relatively short time span, without putting much thought into the design. Programmers can rapidly create code by borrowing objects that are already out there. HTML is the most common form for developing visual representation of web pages and user interface. Now, server-side computing is done in such languages as PHP, Java servlets, Java server pages, Microsoft Active Server Pages using ASP, ASP.NET, Adobe ColdFusion, and nowadays there are all kinds of frameworks and platforms for developing web applications. Now, one language that should definitely be mentioned here is Perl. Now, Perl used to be the de facto standard for handling form data on the web, on the server side. Python, is increasingly used in server-side scripting. PHP is probably number one, especially for small websites, but some server-side, large server-side applications, they're typically written in Java. Even C++ is used sometimes for server-side scripting or server-side applications. Now, a few words about database management systems. Those are the systems that create, store, manage modifications to data in a database. So they make data accessible for queries and reporting. Some of them they also contain, or most of them, they contain data dictionary, which is like metadata, data about data being stored. Large enterprise database management systems for storing all data in relation to an enterprise are called data warehouses. Those data warehouses can be mined or can be queried using a variety of tools, and one of those tools is SQL or SQL. Structured query language. So here you see an example of querying a database for specific information related to customers and orders. Another category of support software includes case tools. CASE stands for Computer-Aided Software Engineering. Typically, case tools, they rely on the so-called UML, Unified Modeling Language Convention. UML standard specifies like those mostly graphical standards for doing software design. So case can be forward, can be reverse. Case means forward means you can create a model for a piece of software using graphical representation that is a part of UML convention, and then your case tool will translate your specifications into code. You can also do it in the reverse way, where some case tools allow you to feed in code, computer code, software code, and then this code will be translated into some kind of UML-based model. Naturally, this is done to aid, and forward case engineering is done to speed up software development, Backward or reverse case engineering is done to enhance understanding of the code by teams of developers. Then you have communication interface software, something related to file transmission of the internet, FTP or HTTP, hypertext transmission protocol. Some other useful utility programs involve archiving software such as zip programs. Now at the end, just to mention like some key software trends, I think nowadays the tendency is towards human coding efficiency. I think this trend is driven by the fact that computers are becoming smarter and more powerful. So people are saying no more assembly-like code. Let's build languages that seem to be closer to human understanding of computing, or to the way human brain works. There's increasing trend towards open source, meaning free support software. What happens is that a lot of organizations, software organizations, are changing their business models. Instead of developing a software package and charging a fee for a license, they give you software for free, and then they make money, in support, or if you want to hire them to customize their open source software or provide you with general advice, they will make money from there. Object-oriented languages, are becoming the de facto standard of programming. There is more emphasis on applications that are run over the internet or intranet, the so-called cloud computing paradigm, or software as a service, where you don't have anything installed on your side. What you do, you load your application from a browser, and data and software logic is accessed over the browser from the internet or from the cloud, as they say. And then there's more use of personal productivity software on microcomputers. I would add one more thing. There's more emphasis on online personal productivity. I'm talking about such software as Evernote, Productive, I already mentioned. And also, something that probably needs to be added here, there's increasing trend towards adding social aspect to software, like GitHub. This is this tool for writing code and collaborating on the web. It's all about kind of social interaction where people can share their code, get other people's feedback, have other people contribute to whatever they're doing. So there's increasing trend for not only group support, but this kind of wider social support of support of kind of social interaction with any kind of application. For example, Google Docs, this alternative version, online version of Microsoft Office developed by Google. And one of the striking features of that software was basically social collaboration, where you can create a document and you can share this document over the web, and people can edit this document in real time, and you can see their changes, you can accept their changes or revert back to the previous version. So that's an example of that kind of social approach to software applications. It's becoming very, very common nowadays. Okay, friends, so that's the last part, the part 4 of our video presentation devoted to chapter 2. I will soon post another case study discussion that you're supposed to, go through, as a part, of the course requirements. So thank you for listening. That's it of part. That's the end of part 4, and also the overall presentation of for chapter 2.